All right, we are moving on. Physics 20, we're on Unit 3 now. Okay, circular motion, which is what we're going to start kind of working on today. And then that's Chapter 5 is circular motion. Then we'll get into Chapter 6, which is work and energy. Okay, so yeah, today we're just going to look at defining circular motion, answering some questions based on that. Okay, so speed and velocity in circular motion. Okay, uniform circular motion, okay, is motion in a circular path with a constant speed. So again, when we've talked about uniform motion before. Okay, uniform motion is always at a constant speed. Okay, it's a scalar value. Again, it's speed, not velocity, because if you kind of look, like you'd think if you have 1 point on this tire, it's going to change its velocity at all times because it's changing directions. Okay, but so that's we're going to focus on speed. Okay, and so this girl's riding on her bike. Okay, she rides through some water, and it sprays up on her back. Okay, oops. Okay, and so the path of the water drops when they leave the wheel is at point A. Okay, and here's our radial line. Okay, our radius. Okay, and our tangent line is always of where it leaves the point on the wheel. Okay, the water on the wheel is continually changing direction. Again, that's why we use speed and not velocity. Okay, so the direction of the velocity of an object in uniform circular motion is always tangent to the circle. Okay, so tangent means coming straight off of the circle. Okay, so if this is point A, this is our radius. Okay, our velocity would be coming straight off. Okay, as you can see in this here. Okay, the 4 different points, our velocities are coming straight off. Okay, centripetal acceleration force. So the direction of the pebble in this case, we have a pebble here, okay, on our bike tire. The direction of the pebble's velocity changes from point A to point B. Okay. And so again, the change in velocity is equal to acceleration. And we can, so the change in velocity is, change in velocity is pointed towards the center of the circle, yeah, as it moves around. So you can kind of see here. So if this is, when we put our diagram together, we have our velocity of A, velocity of B. Okay, our change in velocity is always pointing towards the center of the circle. Okay, and then our centripetal acceleration is acting towards the center of the circle. Okay, centripetal means center seeking. Okay, and so that's where our acceleration is. Okay, when the acceleration is perpendicular to the velocity, the direction of the object is going to change. Okay, and so that's when we're looking at this. This would be our perpendicular. So our direction of our object changes when the acceleration is parallel to the velocity. Okay, the speed of the object changes. Okay, and so that's where our acceleration. Okay, when you throw it up, it's going to slow down, and then in this case, when it comes down, it's going to speed up. Okay, acceleration is the change in velocity. Okay, this includes speed and direction. Okay, so now looking at according to Newton's second law, if a mass is accelerating, there has to be a non-zero net force causing that. So centripetal force is a force acting towards the center of the circle caused by the move in a circular path. A centrifugal force, okay, is the reaction force exerted by the rope on the hand. So the force coming in, okay, it would be our centripetal force, okay, and then the force going out, okay, is our centrifugal force. So the force, again, this is Newton's third law. We have equal and opposite or action-reaction forces. Okay, so the force, we have a force exerted by the hand, by the rope on the hand, pulling it out. and then there's a force exerted by the hand on the rope, okay, that's moving the actual ball. Okay, and then the motion of if you're to release the ball changes depending on at what point you'd release. Okay, centrifugal just means center fleeing. So again, centripetal is center seeking, centrifugal is center fleeing. Okay, centrifugal force is an apparent force. In other words, it is only perceived. Okay, it is simply the inertia of the object that is in the motion. All right, that's this first part. I know section 5.2 and 5.3 are a lot longer, and there'll be like 2 or 3 assignments based on those. Okay, for today, okay, I just want you to go through, read through the check and reflect, okay, and do questions 1 to 4. Okay, and then once you have those done, just comment on this video, okay, with something interesting that you found while doing those questions, okay, or just something that you can tell me about what you did on your week off. I'm sure most of you just stuck around because that's what we're supposed to do. Okay, just you're just gonna, your whole mark for assignment 5.1 is going to be based on whatever comments you leave, okay, on this video.